Good morning, class. My name is Katwaka Sebedesho, and I'm here with my fellow classmate, which is Bishop Salakai. So today, we'll be talking about particle model of matter, which is solid, liquid, and gases. So from here, I hand over to Ms. Salakai to take you through the lesson. Thank you.
Okay, thank you, Mr. Kek. Good morning, class.
Morning, ma'am.
Today, I want us to take a look at what I'm holding. What is this? An ice cube, right? Sorry. This. What do you think this ice cube is? Why do you think this ice cube is hard? And why is it that it keeps its shape? Ne?
Yes, ma'am.
And the second question is, what do you think is happening inside these ice cubes deep down where we can't see it? I want you to take your time and think about that. Let's think about it. So, I want you guys to face your partners and share with them what do you think. Right? I'm going to give you about 2 minutes. 2 minutes. I want you to come forth, all of you, come forth. Just to stand together, then lock arms. Lock arms, ne? Lock arms, yes, like this. Lock arms tightly so. Tightly so, ne? Tightly so. It's tight, ne?
Yes, ma'am.
Okay, so I want you guys to move around. Move around. Is it easy to move?
No, it's not easy to move, man.
So, as you are moving, right? Yes. I want you to think about the particles, right? I want you to think about the particles, ne? Let's say these particles, take this sweet, ne?
Yes, ma'am.
This is a solid, right?
Yes, ma'am.
This is a solid. This is a solid, right?
Yes.
So I want you to think about the particles within that. If the particles are tightly packed or are spread out, right?
Yeah, yes,
Just think about it. Are they tightly packed?
Yes, ma'am.
we are tightly packed.
Are they spread out?
No, ma'am.
Okay. So I want you guys to loosen your arms a bit. Over here there is water, ne? It's a liquid, ne? So I want you guys to imagine, ne? The particles within this. You have loosened your arms. So I want you guys to move. Let's 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 move. How does particle movement change from a solid to a liquid?
We are not
A particle movement change from a solid to liquid.
from a solid to a liquid.
Before it was tight, right?
Yes,
So how does it change from a solid to liquid?
melting.
It loosens up, man.
It loosens up, ne? That's correct. So another thing, I want you guys to free your hands a bit. Free your hands. Then hold this. Yo. Lenas. Lenas. So now we are looking at gases, right? So can anyone tell me, Hori, what's inside the balloon? Air, right? Air is a type of
Yes.
gas, right? So what does this show? Wait, before that, I want you guys to think about the particles within the balloon. How are they arranged, right? As you are standing, you saw how, okay, you have loosened up your arms. You are standing individually. Now I want you guys to move. Move, Tato. Move. Are you able to move?
Yes.
How are you moving?
Freely so.
Freely so, right? So Same applies to the balloon, ne? Can you guys please? So from this sheet, ne, you are going to draw the particles within solid, liquid, and gas. Then you are going to label each diagram whether the spacing is closely packed, whether it is there's space between, and you are also going to present to us what you have learned, ne?
Yes, ma'am.
Yes, so do so quickly, ne? I'm going to give you about 10 minutes. But Ato,
Yes, darling.
okay, let's continue. Let's hear from your group.
Hey, me and Mr. Celebration, we did this one. These are our drawings. This is the state of solid. Solids don't move a lot. They are the particles are tightly packed, which means they use less energy. And then for liquids now, liquids are not very tightly packed. Their particles are loose, but not too loose. And then they have a low movement, which means energy that they use is minimum, average actually. And then for gas, they are loosely packed, as you see the balloon there. The particles inside are loosely packed, and then they have too much energy because they move a lot. There's too much space for them to move. Thank you, man. We are done.
Thank you. The next group, clap your hands. The next group.
So the first state we have is the solid state. So in the solid state, the particles are closely packed and there is less or lower energy between the particles and there's no movement of the particles. Moving on to the liquid state. The liquid state, the particles are not closely packed to each other. And the movement, there's little movement for the particles and there's less energy of the particles to move. Lastly, we have the gaseous state. In the gaseous state, the particles are scattered and the movement of the particles is freely. And because the particles are scattered, it takes energy for the particles to scatter.
Okay, thank you. So there's a quiz. There's a quiz homework. So you complete that quiz. Then, as we summarize, as we close off today's topic, right?
Okay, class, as you have said, we've been listening to Ms. Salah presenting the lesson. So here's a summary of what we've been talking about of piece of matter. Okay, in solidity, particle arrangement, they are tightly packed. When it comes to movement, they are vibrating in place. Energy is low energy is also low in the solid state. When we move on to liquidity, particle arrangement in liquidity, they are close but can slide. Okay? In terms of movement, flow past each other, energy is medium in the liquid state. Moving on to the gaseous state, the particle arrangement there, they are very far apart. When it comes to movement there, they move freely. When it comes to the energy is very high in the gaseous state. Otherwise the particle will be able to move freely. Okay? That's our conclusion of today's lesson. Thank you, Lenas.
Thank you, sir.